Hi, this is Mayloon Math exam regrade. So for the first question, we are looking into the two parents of a sample of offsprings. So what we have is that it tells us that the mother is a Siamese short-haired cat, which means that the gene for Siamese short hair has to be 2 lowercase b, and being short-haired would be capital S or a capital S and lowercase s because short hair is dominant. Both would work. For a black long-haired cat, since black is dominant for the trait, we can get a capital B and a lowercase b, or 2 capital B. Because long hair is recessive, it has to be lowercase s. Now, how do we know if it's S, the S and the B's? Well, we look at the front and we can see that in the kitten given, we are told that there are still 2 long-haired, and as well as there are still 2 black cats, and as well as 2 Siamese. So this tells us that because there is still long hair, the mother has to be heterozygous for the trait, or else it would not pair with the father's recessive trait and to produce long hair. And the same thing for the father. The father would have to be heterozygous for the color trait of the Siamese, because in the kittens there are still Siamese cat, which means that it needs one recessive trait in order to go with the mother trait. This would give us answer number 5 as below. That would go down to the mother as capital S lowercase s BB, or Siamese short-haired, and the father as lowercase s and capitalized B and lowercase b for the black colored and long haired. Okay, next. Now for this question, we are asked for a generation 2 offspring of 2 pure breeding homozygous cats. So in the chart below, we are told, because homozygous means that they're both the same gene. For black would be capitalized B and lowercase s. For the Siamese short cat would be lowercase b and capital S. When we cross the first generation, no matter how we cross them, they would always come down to heterozygous in favor of the dominant trait. And we do the same thing again with the 2 offspring, and we find out that from the Punnett square given, only 3 of the squares matches the one that we are looking for, which is Siamese short cat, which means that they need to have the genes of the 2 recessive trait for the Siamese. And then for the short gene, which could be capital S, lowercase s, or 2 capital S, the answer would give us 3 out of 16, which corresponds to the first choice. The third question is asking us for the chances that a child born from the generation 2 of family 1 and 2 will have Tay-Sachs. Now for this question, we know that from the table provided, in generation 2, there is one child that does have the trait, which means that both of the parents in generation 1 has to carry the gene. It has to be heterozygous. Because the both parents in generation 2 in question are not blacked out, they can either be homozygous for no mutation, or they could be heterozygous for the trait. Because the gene only appears black when there's 2 lowercase t, we can use 2/3 times 2/3, because both of the parents cannot have the 2 lowercase t. Then we add in the 1/4 to the multiplication process, because the chances that the child will end up with the gene because of the 2 heterozygous gene as an independence event. This will give us 2/3 times 2/3 times 1/4, which gives us 4 out of 36, and total to being 1/9 of a chance that the child would develop the mutated disease. And that would correspond to the second option. Lastly, is a question on 5 different gene association of the rabbit. So what's given to us is that the rabbits are heterozygous for the gene, which means that they will all have 1 capital and 1 lowercase, and they are all sorted independently. So we can make each gene a separate factor. When doing the math, as the Punnett square showed, that 2 capitalized gene would be a 4th chance. The heterozygous would be 2 out of 4, and then so on. When we multiply the fractions together, we get 4 out of 1,024. When we simplify that, would be 1 out of 256. And that correlates to the answer in option A. Thank you. That would be it. Hi, Ryan.